In this video, this is what we're going to make. A little cute slime character moving around the screen with 8 directions possible, and collisions. So this is a more modern take on RPGs that allows completely free motion, snapped to 8 directions. Without further ado, let's get started. So first, create our project. In our project manager, new, create a new project RPG, set the location, make sure it's in a folder, and click create. From here, we're going to set up a 2D scene, and this is going to be our main scene. Save this as our main scene. In our project, let's go create new, folder. We need one for art, one for scenes, one for scripts. Let's make sure we stay organized. So then in our main scene, we need a player. So right click, add child node, and search for character body 2D, and name this player. Right click, save branch as scene, and let's put this in our scenes folder as player. So what this does is it creates a brand new scene that contains everything for our player. So that means that in each of our maps, we can just have a copy of this scene, the player scene. The player will be consistent across each scene. So this button opens the scene in the editor. So in here, let's right click and we need a collision shape. And then in our inspector, let's go shape, set it to a rectangular shape. That'll do for now. Add another child node, sprite 2D, and on top of that we also need to add an animation player. So now let's import our art assets. So right click on our art folder, open in file manager, and here's our folder. So what I've done is I've imported a sprite sheet of our animations, and each direction has a different sprite sheet for the animations. These are available in the description. So on our sprite 2D, let's go texture, load, and let's just put south for now. So right now it's showing the entire sprite sheet. Go to animation and there's 10 across and 10 down. So H frames 10, V frames 10. It's all blurry, so go project settings, textures, default texture filter, set it to nearest. So now let's fix the shape of our collision shape. So just drag these in. So now save our player scene, and in our main scene, you see our little players at the top. Our project resolution is really big, we don't need that, so project settings, and go window, and we want it 320 by 180. Set our scale mode to be integer, and set our mode to canvas items. So now it's really small, and our player takes up a larger area on screen. You see it opens in a really small window, so let's go back there, project settings, and also set the mode from window to maximized. So now our little player's on screen. So now let's start scripting. So in our scripts folder, right click, create new script. I'm going to write this in C#, and it's going to be called PlayerController. Now let's double click on our PlayerController, and it opens the script. So first thing I do is I set this to a global class. That's all I do. Go back to Godot and click the build option. So now what we can do on our player scene is right click, add child node, and if I search for PlayerController, by setting it to a global class, it creates it as a node that I can add. So now let's go back to our PlayerController and let's get it started. So since this script is inheriting node, we need to grab a reference to our character body 2D. So character body 2D, player CB2D, that's just our name of it. Inside of our ready function, player character body 2D, and it's equal to the location that it is. So on our player, the script is here and the parent of it is the character body 2D. So in code we want to go this script node dot get parent as a character body 2D. Within our process function, we're going to want to call a new procedure that we create. So move player, and down here we want to go void move player. Easiest thing to do before writing code is to try and plan it out. So first we want to get input. Then we want to set the velocity of the character body 2D, and then we want to call a function built into Godot, built onto the character body 2D called move and slide. So we're going to want a variable that stores our player input, vector2 player input, and by default it's going to be vector2.0. So down here we want to do player input, and we need to have a function that gets our direction. So it needs to return a vector2 get direction. You might be wondering why I'm splitting it off so much rather than doing it in line. This is because if we need to add code in the future to any of these functions, it's easier to do it if it's already split off. For instance, in this tutorial we're doing 8 directions. If you needed to make it so it did 16 directions, you'd have to go in and modify this code versus just finding it in the get direction function. So what we do is we create a local variable vector2 input, and we go input.getVector. So this is saying get the direction based on different inputs. So you see Visual Studio Code is actually telling me what it wants. So negative x, so as we reduce x, it goes to the left. So we want UI underscore left. Positive x is UI right. Negative y is UI up. because as you minus on the y-axis, you're going up. And finally, the positive y is UI down. And now we want to make it so that we only go 8 directions. There's a couple ways to do this. Easiest way in this situation is just to create a new vector2 and math.sign and do input.x and do the same on the y. So what this is saying is math.sign returns the same number as -1, 0 or 1 based on the input. If it's a negative number, it returns -1. If it's 0, it returns 0, and if it's a positive number, it returns 1. So that caps our directional movement to be 8 directions. Up, down, left, right, and the 4 diagonals. Finally, all we need to do is return our input. So now we've set our player input variable to our direction. We want to then grab our character body 2D and set the velocity to be our player input multiplied by a variable for our base speed. So let's create a constant float player base speed and set this to 50 just as an example. So now down here, set our velocity to our player input times by our speed. Finally, we want to call the move and slide function on our character body 2D. So with our script looking like this, we now have 8 directional movement. And because we're using move and slide, we also have collisions. To be able to test collisions, in our main scene, let's create a new static body 2D, and within here, create a collision shape 2D. Now let's just create a random rectangle, make it decently big, and move it into place. To make these debug shapes show up in our build, just go debug, visible collision shapes. So now I don't need a sprite on just to run a test like this. So there we are. You see, our collisions entirely work, and we've got 8 directional movement. That's all fine and dandy, but let's make it look pretty. Before we do that though, if you have an observant eye, you might notice that moving left, right, up and down is at the same speed, but diagonally it feels like we move faster. If I draw out a diagram here, if we're moving up and down, so you can see that the diagonal, we're actually moving probably about 1.4 units, which is obviously more than 1. This is an easy fix. On our return input, we just need to set it to normalized. All that normalized function does is ignore how big the numbers are, keeps the direction, and sets the magnitude to 1. This means that no matter the direction, it will always be capped to 1 unit. As I said earlier, this is why we separate out our code. It means that we can easily change the getDirection function. This means that any reference of the getDirection function will have this fix on. Now let's move on to making the game look pretty. Back in our code, now we want to start setting up making the game look pretty. So we'll need to grab a reference to the sprite 2D, and we'll also need to grab a reference to the animation player. So now we do the same in the ready function, we grab a reference to it. The sprite 2D is a child of the character body 2D, so we can go player sprite 2D. So we can grab the character body 2D and get a child node. So get node sprite 2D. This is based on the name of it, so it needs to be named sprite 2D in the editor. And then we want to go as sprite 2D. And the animation player is a child of the sprite 2D. So the animation player is grab the sprite 2D, get node, animation player, as an animation player. So now we've grabbed all of our references. In our process function, we want to make a new procedure. So animate player, and let's create a new void down here, animate player. Next thing, let's go back to our editor. Select the animation player and go animation, new, and let's call this idle. We would like to set the FPS to 12 FPS and the idle animation is 24 FPS. So now what we can do is we have our animation player selected. Let's go sprite 2D and let's click the key icon, which adds a keyframe, and let's create a reset track 2. So now our first frame is going to be frame 1, frame 2. So let's click the key and that will add it to the timeline. Frame 2, frame 3, and you see the fourth frame actually wants to be our first frame, so 0. Remember, it's 0 based, so the first one is 0, 1, 2, 3. So now, if we click the loop button, you see the idle animation is just it having a little bounce every so often. This is the default animation, so let's click this button here, autoplay on load, and now let's create a new animation, and let's call this moving. Again, we do the same thing. The first frame on the second Y, and let's click the icon, go back to the first frame, and click 1, 2, 3, 4, 5, 6, 7, 8. And so this is 8 frames long at 12 FPS, and we loop it. And that's our little movement animation. Easy peasy. So now we've got our animation set up. Let's go back to our script, and first we want to go if our player input is equal to vector2.0, then we want to set our player animation player.play, and we want to play our idle animation. Otherwise, we want to play our moving animation. Now, the .play function on an animation player will not reset an animation if it's already playing. It will just continue it. This is why we can continually call the play function without it having reset the animation each time. So now in Godot, save our player. So the idle animation plays, and then when I'm moving, it plays the moving animation. All fine and dandy, but now we need different directions. This is the reason why I've set up different directions as different sprite sheets. So there's multiple ways you can set up the animations. You can either have it so you have an animation per direction, which then you call within a script. That's a little bit of a pain to do. Alternatively, you can override the sprite itself while leaving the animation intact. Because of how we set up the sprite sheet, this frame will always be the third frame in the idle animation. The only limitation of doing it this way, every single direction needs every animation to be the same length of animation. That's the only limitation of this method. That and making sure you line up the sprite sheet. So in Godot, let's leave a comment. First handle setting correct animation. Now up at the top, we want to have a list of textures. So we want a texture 2D and north, and we want a gd.load, and we need these brackets to say it's a texture 2D, and we put the location in here. So in Godot, right click our texture and go copy path and paste that in our script. So we need north, northeast, east, southeast, and south. So now we need to override the texture. So let's create a switch case. Switch the player input. So let's create a local variable, in this case, vector2v, when v equals vector2.up. So if we're moving up, we want to change it, and let's write this out for every single direction. So vector2 down, vector2 left, or v equals vector2 right. If vector2 equals new vector2 1 1, so we're moving down and right, or v equals new vector2 left and down. And finally, the same thing, but instead the upwards diagonals. Actually, I will change that order so it's slightly better. So that makes the most sense in order. So up, diagonal up, left and right movement, diagonal down, down. So now let's create a new procedure. Void set player sprite texture 2D. So that takes a texture 2D. And first, we want to just go player sprite 2D dot texture equals t. That's all we need to do for now. So inside of each of these, we just want to call the function set player sprite. And if we're going up, it's north. If we're going diagonally up, it's northeast. Left and right is east. Down diagonal is southeast, and down is south. So if we go to play the scene and move up, it works. If we move down, it works. If we move left or right, it works. But the diagonals do not work. We're checking against the player input. This means that these vector 2s aren't correct. So after each one of these, we just want to put normalized after it, because we've normalized the direction up here as well. So now diagonals also work. However, if we go left or right, you can see we're not facing the correct direction. So within our set player sprite, now let's go if the player input .x smaller than 0, so that means we're facing left. We want to grab the sprite 2D and flip horizontally equals true. and we want to do an else if we're facing the opposite direction. We want to set it to false. You might be wondering why I'm not doing an else statement there instead. If the input is none, we want to leave the character facing the direction it already was going. So if the player input is 0, we don't want to do anything to the flip. We don't want to do anything to flipping it horizontally. So now back in Godot, finally, we have 8 directional movements all working, including our collisions on this object. And that is how to make a modern RPG character controller in Godot. If you want to know more about building RPGs in Godot, stay tuned and there will be more videos coming soon. So like and subscribe and I'll see you in the next one.